Put it on the Keurig machine, and this is it right now with the shorten of the thermistor, so it should be on its original settings. It preheats, then the water will reach up. When it actually puts out the cup, we'll measure it. Right, when it's preheated, the device then asks to lift and begin. No cartridge inside, but what we'll get is just straight hot water. Continue, and it should dispense water. Down 8 ounces. Start. Alright, press start to start. It's now come out. Let's see what we get. 72.1 degrees Celsius. 72.0. Okay, so 72 degrees Celsius. At the back of the device, it's preheating again. This is with the the pot on, so I'm adding a resistance. This should be around 1400 kilo ohms. So we'll see what that does. Theoretically, that should increase the temperature. Lift to begin, so let's do that. So it's filling, you just have to wait till it's finished and do the test and see if you've been successful in raising the temperature. Right, the temperature with that 79 degrees, 79.1, 79.1, so 79.4 is the highest, almost 80 degrees. So the temperature has risen. This, what I've done is raise the resistance slightly more, as you can see from the tape. I need to just test this when I go home with a thermometer, multimeter, and see what the resistances are. But when it reaches that far up, it continues and it's stuck in the preheating stage, and the device never actually picks up that it's reached the correct temperature to move forward. And basically, I think the thermal overheat kicks in and it just does not reach past this stage. So we have a limit. We established what we can get. Before, in a previous testing, we've gotten up to 82 degrees Celsius, which is fairly good. It is in excess of what we wanted. So experiment successful. What I'll have to do is replace that now with a proper form factor pot, so that we can actually get that to fit in the little space below the machine. Gonna run at increased temperature. Let's see what we get this time. 81.3, 81.3, 81.1, so 81 degrees Celsius. One hasn't seen the previous strip down. This is the area I'm talking about below. The pot has to fit in, so it's a nice enough space. You can fit it in there. Right now I've just jimmied it out to come out, so there's a connector in there. It's just to put the pot in there and get the correct resistance. Now that we are at the end of the video, let's address the engineering behind this. How did we know it was a 50K thermistor? Well, as you would have seen in the last video, we were unable to get to the thermistor, so some estimations had to be done. Measuring the value, taking the connector off and measuring the value with a multimeter, yielded about 40 kilo ohms. And that occurred when we were at around 29-30 degrees in the apartment, which makes sense for it to be a 50K thermistor. Watching the two highlighted values, they match up, so that's how we knew what we were working at with. Next thing now, let's address what we basically want to achieve. What we wanted to achieve, the guess was that this thing was basically around 79 degrees Celsius. I did not have a digital thermometer at the time, one of those infrared digital thermometers, so the guess was basically around 79 degrees. And again, guessing that we were basically getting 1.4K less because the slide was moved, right? And thereabouts was the average, and that's what I started off with, and saying that we want to go from that 79 to around 87 degrees Celsius, which was what we expected we could have done. That gives us the 1.4. What really happened in reality is actually while the water was coming out at 72 degrees Celsius, and then we were able to bring the temperature up to around 81 degrees Celsius. Reality is the thermistor inside was reading a much higher temperature at our 1.09 kilo ohms that we were working at. That basically corresponds for a 9-degree rise, which is what we see, assuming that the water lost some amount of heat on the way out, and really dodgy estimation that it lost the same amount. We have a 9-degree rise in temperature, which corresponds to 1.1 approximately kilo ohm. And if we look at the green highlights, we can see that if the temperature of the water sensed by the thermistor was 88, and then we add a 1.1 kilo ohm resistor to it, we will basically get that water up to about 97 degrees Celsius and basically fool the micro up to that level. And that again clearly shows now that if we were to add 1.3 right kilo ohms, we are going into the 100-degree range, which is pretty much where things start to get hairy, and which is why it was not responding. So basically inside, the temperature the thermistor was sensing was actually 88 before, and we have now moved it and basically put the temperature at that point to 97 with an output of the 81 thereabouts that we're seeing.